Okay, as I mentioned last week, we're going to get into the type of statistics that I'm a lot more familiar with, that is hypothesis testing. Just this here. Um, so let's talk about some of the fundamentals of that right now. Uh, okay, let me just switch. Okay, there we go. All right. Basically, today, or in this session, we're going to talk mostly about null and alternative hypotheses. Um, we'll get into a little bit on what that means right now. So we've all heard lots of claims about population parameters that, 4 out of 5 dentists prefer Trident or Starbright toothpaste or whatever. Less than 1% of dogs attack people unprovoked. We hear these claims about population parameters quite often in the media. Um, and we make decisions based on these claims. Sometimes it's, what type of gum we choose to chew if we're worried about our teeth, or what type of toothpaste we use, or whether or not we think that dog is safe. Sometimes they're very important, sometimes it's fairly minor. The real question here is, how do we actually test these population parameters that we're presented with, if our job is actually testing those claims. Hypothesis testing is a process we use for doing this. A hypothesis is a theory or claim that someone is making that has to be investigated. And science, a hypothesis is something about how the world works. In statistics, it's a claim about the numerical value of a population parameter, such as the mean, proportion, or variance. So 4 out of 5 discs is a proportion. Less than 1% of dogs would also be a proportion in the previous example. All right, so the first step in hypothesis testing is to state the research hypothesis. This is the hypothesis that this is our idea of how things should be. This is also called the alternative hypothesis, and it is denoted by H sub A. It's the as it says here, it's the hypothesis that we are aiming to gather evidence in favor of. This is called the alternative hypothesis. The other hypothesis then is the null hypothesis, which is H sub 0. It is the logical opposite of the alternative or research hypothesis. This is called the alternative hypothesis because the null hypothesis is assumed to be true. So the research is aimed at disproving is too strong a word, but the research is aimed at failing to prove the null hypothesis. The other thing it says here is that equality must be included in the null hypothesis. The first example will show exactly what we mean by that. So we're trying to see whether or not we can reject the null hypothesis. So the data that we come up with has to provide enough evidence to reject the null hypothesis, and it needs to be overwhelming evidence. Usually you want it to be a 5% or less chance that the null hypothesis could explain your data. Okay, so review here. Hypothesis testing is a technique for testing a claim about a population parameter. The alternative hypothesis or the research hypothesis is the claim that we are gathering evidence in favor of. So, and we'll get into that in the examples. The null hypothesis is the mathematical opposite of the alternative hypothesis and includes equality. All right, so here's the first example. It's probably the easiest way to see kind of the difference between the null and alternative hypothesis is through the example. So at a community college, the syllabi for an online class states that students should expect to spend 10 hours per week doing homework for each 3-credit hour class. The director of e-learning thinks that they might be spending more than that, and he wants to know. Okay, so what he's wanting to gather evidence for is that students are spending more than 10 hours on coursework. So his research hypothesis or alternate hypothesis is that the average, in this case, hours of students doing hours of coursework needed per 3 credit class is greater than 10. So the logical opposite, which has to include equality, is that it is less than or equal to 10 hours. So that's our null hypothesis, right? It does include the equality, I guess, of that being equal to 10. So the hypotheses are written as the null hypothesis, the mean is less than or equal to 10. The alternative or research hypothesis, the mean is greater than 10. Okay? So this one, go ahead and take a minute, pause it, and resume when you're ready to see the answer for the null and alternative hypothesis for this. Wow, that is a long time to hold your breath. All right, so there's 2 pages worth of question here, so give you a minute. Here's the second page with question. Okay. Amount of time you can hold your breath apparently varies with water temperature, possibly. Okay. So, they're wanting to test if the claim about adults holding their breath on cold water is different than the claim of 30 seconds for adults holding their breath in lukewarm water. All right. So, they're investigating whether the amount of time an adult can hold breath is different than 30 seconds when the water is cold instead of lukewarm. They're simply interested in whether it's different. They don't care if it's greater or less than. So the research hypothesis is that the mean is not equal to 30. The logical opposite is that the mean is equal to 30. So that's the null hypothesis. So we can write those that way. If you haven't seen it before, that little symbol, the equal sign with the slash through it, is for not equal. Okay. I want to know what the result is. I don't know about the rest of you, but all right. But moving on. So another scenario. Again, pause, figure it out, unpause when you're ready to move on. All right. So if we've got a new study that claims the president's job approval rating has dropped over the last 3 months, previous polls had a minimum approval rating of 56%, and the chief of staff is concerned because it is an election year and he wants to run a test on the claim. Okay. So think about it. What's the research and null hypotheses here? All right, so we're after a population proportion, right? The percentage of the population that feels a certain way is a proportion. The claim being tested is that the approval rating has dropped since the poll that gave 56%. So that is that the proportion that approves of the president's job is less than 56 or 0.56. That is our alternative or research hypotheses. So the logical opposite is that it is greater than or equal to 56%. So we can write in this way, the null hypothesis that we're doing the test, we start off with the assumption that it's true, is greater than or equal to 0.56. The research, what we think is really happening is that it is less than 0.56. Okay, next scenario. Super Bowl viewers found survey of Super Bowl viewers found that 8.4% said that they were influenced to buy products from companies that advertised during the game. Because of the rising cost of advertisements during the Super Bowl, which are rather spendy last I heard, Um, One company president has threatened the advertising team with not renewing the Super Bowl ad spot unless they get the results they want. He says that unless the company's ad stimulates at least 8.4% of viewers to buy products, they will not be airing an ad during the Super Bowl next year. Okay, so again, we're going to be after a proportion. We want, well, figure out what the null and alternative is, and unpause when you're ready to move on. Okay, so what is the company's president researching? He does not want to cancel the ad unless there's overwhelming evidence that the percentage of viewers persuaded to buy their product is too low. So the research hypothesis is that the percentage is less than 8.4%. So if the proportion is less than 8.4% or 0.084, that's what he's afraid might be happening. The mathematical opposite of that is greater than or equal to 0.084. So there's our null hypothesis, the proportion being greater than or equal to 0.84, and the research hypothesis of being less than 0.084. Okay, so we know how to identify our null and alternative hypotheses. So the next step is to decide which two the data support. Our hypothesis test will compare the merit of these two hypotheses by examining the data. As it says here, we do not treat these hypotheses equal. We the null hypothesis is, we can think of it as describing what is currently accepted, which is why it includes the equality, why it's less than or equal to or greater than or equal to. So we start off by assuming that the null hypothesis is true. So what our hypothesis test really does is determine whether or not the data is consistent with the null hypothesis being true. If the data disagrees enough with the null hypothesis, then the null hypothesis is rejected in favor of the alternative hypothesis. The terminology here is fairly important. We don't say that it is disproven or that the alternative hypothesis is proven. We say that the null hypothesis is rejected. Okay, so with some new terminology again, we've got a test statistic, and that's the value that's used to make a decision about the null hypothesis, and it's derived from the sample statistic. Sample statistic is statistically significant if it is far enough away from the presumed value of the population parameter to conclude that it. Well, I don't need to read that for you. So the sample statistic, for example, in one of the population proportion examples, the only one that comes to mind right off the top of my head is the one about presidential approval ratings. So our presumed value was 56% or 0.56, right? If our sample statistic, so the proportion we get from our sample, is far enough away from that 56%, then it is statistically significant. We use the test statistic to determine whether or not it is statistically significant. We will talk about test statistics fairly soon. The other part of this is level of significance, denoted by alpha. Again, alpha is 1 minus c, c being the confidence level. It is the probability of making the error of rejecting a true null hypothesis. So in the presidential approval rating example, 0.56 was the presumed value. if we come up with an answer and we can be 95% sure that, sorry, we end up 5% sure that our answer is, I'm phrasing this poorly, I'm sorry. 5%, it's as they presented it, the alpha is the probability of making the error of, is the probability of rejecting a true null hypothesis. You can also think of it as the probability that the null hypothesis could explain your data. So it's similar concept. So it's really a 5% chance if we're looking at a 95% confidence level or 5% significance level. It's a 5% chance that the null hypothesis was true. Usually we pick some limit. 5% is fairly standard. So you can't say we're 100% certain that this is the value. It's, we're 95% certain that it's different, or 5% certain that the other case, the null case, could explain things. In essence, your test statistic is looking at a confidence interval for the population parameter, constructed using the methods we talked about last week. We consider the evidence statistically significant when the sample statistic falls outside of the confidence interval for the presumed value of the population parameter. So if we had sorry, I phrased that backwards. If we take our measured population parameter and build a confidence interval around it, if the presumed value falls outside of that confidence interval, then we have statistical significance. So, our sample statistics, sample population parameters, of course, are, the sample mean, the sample proportion, sample variance. We didn't talk about testing for variance. We're not going over that. The test statistics, it really comes down to z-scores, t-scores, or again, we didn't cover chi-squared distributions either. So if our hypothesis is clearly tested, we need to figure out which distribution we need to use and for the test statistic, and we need to know the level of significance. Then, gathering the data, need to use appropriate sampling techniques as we discussed early on in the semester. And then you have to draw conclusions based on the calculations. The real conclusions for the statistics part is you reject the null hypothesis or you fail to reject the null hypothesis. You're not proving anything. It is a stronger conclusion to say we reject the null hypothesis in favor of the alternative. Failing to reject the null hypothesis doesn't mean that the null hypothesis is right. It just means that there's a larger than you're willing to accept chance that it might be. Once you've either accepted or rejected the null rejected or failed to reject the null hypothesis, then you can talk about what that means. It's useful and actually fairly important to provide a well-written claim of what your things mean, what your statistics mean. So in our community college example, who was concerned that students spent more than 10 hours per week during work for the 3-credit course. He did a hypothesis test with 5% significance level, um, and he rejected the null hypothesis. Does the conclusion support his claim? All right, so let's review his hypotheses. Null hypothesis was less than or equal to 10 hours. Alternative hypothesis was greater than 10 hours. Um, null hypothesis was rejected, so the evidence supports the alternative. So we can be fairly confident that students study more per week on average. It's important that it is on average than the time stated on the syllabi with the 5% level of significance. All right, so next example. Board of Education for a large school district believes that the percentage of high school sophomores considering dropping out of school is at least 10%. High school counselor thinks that this is too high. They did a hypothesis test with the alpha equals 0.02, so they want to be 98% certain that it's different, or uh, their result was failing to reject the null hypothesis. Do the findings support the counselor's claim? All right, so the counselor's claim was that the percentage of high school sophomores considering dropping out was less than 10%. So he was thinking that P being the proportion, the percentage of high school sophomores thinking of dropping out was less than 10%. Logical opposite, that it was greater than or equal to 10%. We can write them as such. Failed to reject the null hypothesis, so all it's really saying is that the evidence is not strong enough at the 2% significance level, or 98% confidence level, uh, to support the counselor's claim that the rate is too high. Does not prove that this is true. It shows that they don't have the right evidence to reject it. There's not sufficient evidence to reject it. Okay, so perform a hypothesis test, state your hypotheses and the null hypothesis, um, determine which distribution to use, and it's going to be the appropriate distribution for the appropriate confidence interval. So Z normal distribution, or Z statistic for proportions, and if you happen to be lucky enough to know the population standard deviation, T statistic if you for a sample mean where you don't know the population standard deviation. Gather your data, calculate the sample statistics, draw your conclusion, and interpret the data. There are types of errors in hypothesis testing, and again, need to stress that if you fail to reject the null hypothesis, it doesn't mean your null hypothesis is supported. It only means that the evidence does not support the alternative hypothesis. The other thing that's important to remember is that neither hypothesis is proven in either case. There are two types of errors that are possible. You can either reject a true null hypothesis or fail to reject a false null hypothesis. These are given in this handy-dandy little table, which is also on page 599 in your textbook. It's figure 10.2. Rejecting a true null hypothesis is a type 1 error. So this is this is alpha here. Alpha is the probability of having a type 1 error. Failing to reject H naught, So if you've got a false null hypothesis that you fail to reject, that's a type 2 error. As I said, our decision criteria, our alpha is the idea of minimizing the chance of committing a type 1 error. Probability of committing a type 1 error is our level of significance. That's the same level of significance we used for drawing conclusions and hypothesis test. It is the same as 1 minus the confidence level we're looking at for confidence intervals. The smaller that level of significance, the more evidence you have to have. So, and as I said several times, most common practice in academic research is to use 5%. If fairly frequently, not that people don't always supply the level of significance, they just state the probability that the results would occur under the assumption that the null hypothesis was true. And let the readers determine if the null hypothesis should be rejected. We can really choose any significance level we want. Why wouldn't we want it to be as low as possible? Because that increases the chances of committing a type 2 error, which again was failing to reject a false null hypothesis. This one is, they call beta. The less chance you have of making a type 1 error, the larger chance you have of making a type 2 error. Think of it like a seesaw. As alpha goes down, beta is going to have to go up. As alpha goes up, beta is going to go down. So the less chance you have of accidentally failing to reject a false null hypothesis, the more chance you have of rejecting a true null hypothesis. Okay. So what type of error is given here? We've got a TV executive who thinks that at least 99% of the U.S. households have at least one television. And he, handed this job off to an intern to come up with the statistics and prove it one way or the other. After this is completed, based on the sample collected, the intern decides not to reject the null hypothesis. Somehow we know that in reality it's 96.7% of households. So was an error made, and if so, what type? Okay, so first step is, of course, to figure out what our hypotheses are. Research hypothesis is going to be determine if the percentage is less than 99%. The null hypothesis, or what the executive thinks it is it's going to be greater than or equal to 99%. Right? So we can write those thus. So he has failed to reject the null hypothesis. In this case, our actual value that we somehow magically know is 96.7%. So the null hypothesis is false. He's failed to reject the null hypothesis, which is a type 2 error. Okay? All right. Insurance companies apparently like to use 1,000 miles as the average number of miles a car is driven per month. One insurance company claims that because our society has gotten more mobile, the mean is higher than 1,000 miles per month. It tests this claim with the hypothesis test and decides to reject the null hypothesis, meaning, well, we'll get to that. We need to, of course, figure out what our null and alternative hypotheses are. Let's say that in reality, the mean number of cars driven per month was 1,250. Was there an error, and if so, what type? Okay. They're wanting to show that the mean is more than 1,000 miles. So the research hypothesis is that the mean is greater than 1,000. The opposite, the null hypothesis, is that the mean is less than or equal to 1,000. Thus, um, since they failed to reject the null hypothesis, their data tends to support the alternative hypothesis that the mean should be greater than 1,000. If the actual true mean was 1250, which is outside of what's covered in the null hypothesis, there was no error made. Okay, next one, and I believe this is the last one. A study on the effects of television viewing shows that children watch an average of 4 hours of television per night. Someone named Kiko believes that the number of hours children in her neighborhood watch TV is not 4. Performs a hypothesis test and rejects the null hypothesis. If in reality children in her neighborhood do watch a mean of 4 hours of television per night, did she make an error, and if so, what type? Okay, so she believes the mean is not 4, so mean not equal to 4. Logical opposite would be mean is equal to 4. Null hypothesis is the mean is 4. Thus, so she decided to reject the null hypothesis, meaning she thinks her data supports the mean not being equal to 4. If in reality the mean is equal to 4, she has rejected a true null hypothesis, which is a type 1 error. It is important to know that you really do not know what the reality is normally. So we've really got no basis for determining if a type 1 or type 2 error has been made. You can get some of that from other studies, and usually you get a preponderance of evidence over multiple studies that show if one of them is in error. Why it's important to talk about the types of errors and how they're related. It's really about helping to interpret decisions. If you know that it's a 5% chance of committing a type 1 error, you can kind of decide how much weight to put on that. Okay, and that is it for this session. Oops.